Assalamualaikum and good morning. My name is Danish Fathin Rosnizam from the Faculty of Earth Science, University Malaysia Kelantan. Today I will present my research entitled Application of Electrical Resistivity Imaging or ERI for Subsurface Delineation of Agriculture Soil Contamination in Perlis, Northern Malaysia. My background is groundwater is a critical alternative water resource in Malaysia, especially in agricultural areas. However, improper waste disposal and landfill leachate a toxic liquid that can migrate downward and threaten shallow groundwater. The problem is conventional soil assessment in Perlis rely on point-based sampling. They cannot map the continuous lateral and vertical movement of contaminated plants. Without advanced imaging, we don't know the true depth or footprint of soil degradation in Perlis paddy fields. I have three objectives. First, map subsurface resistivity anomaly using 2D RI. Second, characterize soil pH, EC, organic matter, and texture. Third, integrate resistivity model with soil data to produce a contamination map. And my study area is these solutions take a place in a paddy field within the MADA irrigation seam in Perlis near Arau or Simpang Empat. The soil is quaternary alluvium, which is heavy in clay, insectisol, and flat. It was seasonally flowed with intensive NPK fertilizer use. My scope was 2 ARI profile 100 to 200 meter each, will image down to about 10 meter depth, and 6 to 8 shallow soil sample will be taken at 0 to 20 and 40 to 60 cm analyzing plumbum, cuprum, zinc, and soil pH, electric pH, EC pH, and moisture content. This study showed that closed landfill or long-term farming can remain pollution sources. It validated ERI as a non-invasive alternative to borehole and help authority plan a remediation. And then the three key findings from past work. From the agrochemical legacy, phosphate fertilizer introduced heavy metal, cadmium, zinc into Malaysian soil by Kanif Salmijah, 1996. Regional baseline, Perlis soil are within normal geochemical range, but only upper 0 to 5 to 50 cm was studied. Al-Mahayi et al. 2012. ARI detection fertilizer leachate at a dissolved ion, creating a low resistivity anomaly, 10 to about 50 ohm, against backgrounds 60 to 200 ohms. This has been proven effective for mapping contaminant plums by Thomas Bett 200 Benson et al. 1997. Slide 4, methodology. I will explain about my flow chart. My methodology follow a 5 simple steps. Step 1, prepare a slide based on MADA selection paddy field that about 160 meter transect and record the elevation. Step 2, ERI survey. I use the Werner Schlumberger array that use 32 electrode at 5 meter spacing, imaging down to 10 to 12 meter. And step 3, targeted soil sampling. Based on ERI pseudo section, take sample from high, low, and intermediate resistivity zone at 2 depth. Step 4, lab analysis. Measure pH, EC, organic matter texture, and heavy metals such as plumbum, cuprum, and zinc using AAS. Data integration. Invert ERI data to 2D cross-section. Then correlate resistivity with geochemistry using Pearson R. This diagram show that subsequential flow with feedback loom from sampling back to RI and from interpretation back to inversion. And then I will present my budget. Let me briefly present the research budget. The total estimated cost is RM 740 ringgit, broken down as my transportation to Perlis, 300 ringgit, car rental and petrol for return travel to Perlis over 3 days, accommodation 200 for about 2 nights near Simpang Empat, field consumables such as sample bag, marker, pens, electrode maintenance, 80 ringgit, thesis, printing and binding, RM 160 ringgit, for cover of hard copy. The laboratory usage costs are RM0. All facilities such as oven, muffle, furnace, AAS, glassware, region are provided by the department, University of Malaysia Kelantan. And I expect the result based on my methodology. I expect low resistivity anomaly 10 to 50 ohm within the top 0 to 2 meter, contrasting with background 60 to 200 ohm soil. Soil sample will show highest plumbum, cuprum, zinc, and EC in the 0 to 220 layer, decreasing at 40 to 60 cm, indicating downward migration. A negative correlation, R square, more than 0.6 between resistivity and contaminant indicates lower resistivity, meaning higher contamination. A final contamination hotspot map to guide a MADA to remediate the location. And lastly, I will present my conclusion. In conclusion, this study integrates geophysical ERI and geochemical approach to map agricultural soil contamination. The combination will provide a comprehensive understanding of contaminant distribution beneath paddy field in Perlis. Thank you for your attention. I will welcome any question. That's all for me. That is Fathin. Thank you.